Hello everyone, welcome to my channel. Today I discuss about complex analysis, mainly number system and analytic function. So please see this video very carefully. At first we discuss about natural number. The counting number starting from 1 is called natural number. For example, we can write 1, 2, 3, 4, dot dot. So when 0 is added to the natural number, then it is called whole number. So from 0, 1, 2, 3 dot dot is called whole number. Now we discuss about integer. So the number containing whole number and negative of natural number is called integer. So we can write from minus infinity to plus infinity including 0 is the integer. Now we discuss about rational number. A number in the term of p by q where q not equal to 0 is called rational number. For example, we can write 1 by 3, 3 by 4 like that. Now the number of which cannot be expressed as the ratio of the two integers is called irrational number. For example, we can write root 3, root 6, root 8, etc. Now we discuss about even and odd number. So the number exactly divided by 2 are called even number, and the number which are not divided by 2 are odd number. Now we discuss about prime number. So the number which are only two factor, the number 1 or the number itself is called prime number. For example, we can write 2, 3, 5, 11 dot dot. And you remember the smallest prime number is 2. Complex number represented as z is equal to a plus ib, where a is the real part and b is the imaginary part of this complex number. So now we find the real part and imaginary part of a complex number. Suppose given z is equal to 1 by 2i. Question asked, what is the real part and imaginary part of this complex number? We know z is equal to a plus ib, which is the form of a complex number. So we represent it in the form of this. So that's why we multiply both sides by 2 plus I. So we can write 2 plus I into 2 minus I, a plus b into a minus b. So we can write it 2 plus I divided by 2 square minus I whole square. So I is equal to minus 1 means minus minus plus. So 2 plus I by 4 plus 1, that means 5. So we can write z is equal to 2 by 5 plus I into 1 by 5. So we represent it in the term of a plus ib, where a is 2 by 5 and b is 1 by 5. So the real part of this complex number is 2 by 5 and the imaginary part is 1 by 5. Okay, we know I square equal to minus 1. Okay. So question asked, find the value of I to the power 100. How you calculate it? Very easy. I square equal to minus 1. So I to the power 4 is equal to I square whole square, that means minus 1 whole square. So I to the power 4 is equal to 1. So I 100 means we can write I to the power 4 whole to the power 25, that means 1 to the power 25, that means 1. So we can say that I to the power 100 equal to 1. Now we discuss about polar form of complex number. If any complex number represented by a point px comma y in the complex plane, then we can write z is equal to suppose x plus iy. Let r theta be the polar coordinate of the point P. So we can easily write from this. So x equal to r cos theta and y is equal to r sin theta. R sin theta. So this is equation 1, this is equation 2, squaring 1 and 2 and we add them. So x square plus y square equal to r square. So r is equal to root over of x square plus y square, and we divided 2 divided by 1. So sin theta divided by cos theta, which is equal to y by x. So theta is equal to tan theta is equal to y by x, that means theta is equal to tan inverse y by x. So in Cartesian coordinate, which is x comma y, so in polar coordinate we can write it is r comma theta, where the relation between Cartesian coordinate and polar coordinate, r is equal to root over of x square plus y square and theta is equal to tan inverse y by x. If we put this value, so z is equal to x plus iy, so we put this value, z x means r cos theta plus I into r sin theta. So if we common the term r cos theta plus I sin theta, so z is equal to r e to the power I theta, where r is equal to root over of x square plus y square and theta is equal to tan inverse y by x. So we calculate the polar form of complex number, r z is equal to r e to the power I theta, where r is equal to root over of x square plus y square and theta is equal to tan inverse y by x. Now we solve one important question: what is the value of I to the power I? Suppose I we can write cos pi by 2 plus I into sin pi by 2 all to the power I. देखो cos pi by 2 value 0 and sin pi by equal to 1, that means it is I only. So we can write e to the power I pi by 2 whole to the power I, that means e to the power I square pi by 2. I square means minus 1, so I to the power I value e to the power pi by 2. That now we discuss another important problem, that find the minimum value of n given 1 plus I by 1 minus I whole to the power n is equal to 1. So we calculate the minimum value of positive integer n. So we can write 1 plus I by 1 minus I whole to the power n equal to 1. That we can write 1 plus I into 1 minus I into 1 minus I whole to the power n is equal to 1. So 1 minus I into 1 plus I, that means a square minus b square, which is equal to 2, and if we multiply this term we get 1 minus 1 plus 2i divided by 2 whole to the power n equal to 1. So 2i by 2, that means I to the power n equal to 1. So I to the power n, 1 is equal to, we can write I to the power 4. This is the minimum value of n. So n is equal to 4. So the minimum value of positive integer n is 4. Another question, find the polar form of minus 8i. So we know z is equal to x plus iy, where x is the real part, y is the imaginary part of complex number z. So here only z is equal to minus 8i. So here x equal to 0 and y is equal to minus 8. So r is equal to root over of x square plus y square, that means root over of 8 whole square means 64, that means r is equal to 8. Now theta is equal to tan inverse y by x. Y means minus 8, x means 0, that means tan inverse infinity equal to tan theta is equal to tan inverse tan pi by 2. So theta is equal to pi by 2. So r is equal to 8 and theta is equal to pi by 2. So the polar form, we know z is equal to r e to the power I theta, that means z is equal to r e to the power I pi by 2. So also we can write 8 cos pi by 2 plus I sin pi by 2.